Welcome to lesson 1-9 on inverse functions. So the inverse of f of x, it's denoted this way. Okay, this is not a power. That is the symbol for inverse. So you can read this as f inverse or the inverse of f. So if we let f of x and g of x be two functions such that f of g of x is equal to x for all x in the domain of g, and g of f of x is equal to x for all x in the domain of f, then we can conclude that f of x and g of x are inverses. So this is what we do if you're asked to show algebraically that two functions are inverses. We calculate both compositions. The domain of f of x must equal the range of f inverse, and the range of f of x must equal, must equal the domain of f inverse. So inverse, for inverses, range and domain interchange. So we're going to find f inverse informally, meaning we should be able to basically do this in our head because it's a pretty basic function. And then we're going to verify that f of f inverse is equal to x, and f inverse of f is equal to x. So when I look at this function, okay, it's 8 times x. So the inverse of that, the inverse of multiplying, is dividing. So f inverse is x over 8. So what I'm going to do is take f of f inverse. So I'm starting with the outer function, right, the f function, which is 8 times something. And in those parentheses, I'm putting the inner function, which is f inverse. So if I have 8 times x over 8, that gives me x. Then I'm going to do this composition, f inverse of f. So now I'm starting with the outer function, which is something over 8, and plugging in the inner function, which is 8x. So 8x over 8 also gives me x. So I can say, therefore, f and f inverse are inverses, are truly inverses. Okay, so I just showed that by doing the compositions. Okay, let's try another example. So here I have 2x minus 3. So remember, to find an inverse, you're interchanging x and y, okay, and solving for y. So if I rewrote this as x is equal to 2y minus 3, to solve for y, I would be adding the 3 and dividing by 2, which gives me f inverse equal to x plus 3 over 2. So now I'm going to verify that they are inverses. And I'm going to start with the f function, 2 times something minus 3. That something is x plus 3 over 2. The 2's reduce, and I'm left with x plus 3 minus 3, which is equal to x. Okay, I also need to show the other composition. So now I'm going to take f inverse of f. So I'm going to start with that outer function, which is x plus 3 all over 2. And in the parentheses, I'm going to put the inner function, which is 2x minus 3. Okay, so I'm just putting the parentheses there to show what's going inside the inner function. I can drop them. I really don't need them here. And I would have 2x minus 3 plus 3, so the 3's cancel out. 2x over 2 is equal to x. So that verifies that I did find the correct inverse, okay, and that my expression x plus 3 over 2 is the inverse of 2x minus 3. Okay, find f inverse for f of x equal to x plus 2 over x minus 5. So again, I'm going to interchange x and y. Okay, and then I need to solve for y. Okay, so what I'm going to do is cross multiply and distribute the x, so I have xy minus 5x is equal to y plus 2. Now, I'm solving for y, but I've got y in two different places. So what should I do here? If you're saying bring the terms with the y's together, you're correct. So I'm going to take the y and subtract it to the other side, and I'm going to remove this negative 5x, add that to the other side. Now that I have my terms with the y grouped together, I'm going to factor that out. And now I can divide by x minus 1, and I will have solved for y. So there's my final answer of 5x plus 2 over x minus 1. And that is f inverse. Okay, now I'm going to find the inverse of this function, the square root of x plus 3. So again, let's interchange x and y. I'm going to square both sides, subtract the 3, and if I stop here, I'm actually not correct. F inverse is not x squared minus 3. Sorry, F inverse of x squared minus 3. This is the graph of a parabola, right? It's a full parabola that's shifted 3 units down on the y-axis. What is this the graph of? If you said half a parabola, that's correct. It's half a parabola that's shifted 3 to the left. So it looks something like this. So I can't have a function that's a full parabola that's the inverse of a function that's only half of a parabola, right? They have different, they don't have those domains and ranges interchanging the way they should be. So if I look at this graph, the domain of this graph is from -3 to infinity. The range of the graph is from 0 to infinity. Remember, that range becomes the domain of the inverse. So this function needs to be followed by a restriction where I say x has to be greater than or equal to 0. So now what that does is, instead of having the full parabola, I'm restricting the parabola to just the right-hand side, so it would only be this part. And then you can see we have that symmetry over the line y equals x, which is what all of your inverses should have. Okay. So just remember, this is the tricky case. When your function is a radical function, you need to think about that restriction. Again, I have to have matching domain and range. And now I do, right? The domain of this is negative, the domain of my inverse goes from 0 to infinity, right, which was the range of the radical function. And my range of the inverse now goes from -3 to infinity, which was the domain of the original function. So graphing inverses, as I just said, the line of reflection is the line y equals x. We can use the horizontal line test to determine if the inverse exists. So what we mean by that is we say the inverse exists if the inverse is a function. So if I have a graph, go back to the idea of a parabola, that fails the horizontal line test, meaning I have 2 points of intersection with that horizontal line. This fails the test, which means its inverse does not exist. If you can picture the inverse of this, it would look like a parabola that opens to the side, and that would fail our vertical line test. So the horizontal line test is done on the original function, and it saves us from having to find the inverse, graph the inverse, and do the vertical line test. We can do the horizontal line test on the original function, and if it crosses through 2 or more points, it fails and the inverse does not exist. A one-to-one function means that each dependent variable corresponds to exactly one independent variable. So f has an inverse function if and only if f of x is 1-to-1. So find the inverse of f of x equal to 2x minus 7 and call it g of x. And then show algebraically that f of x and g of x are inverses. So again, this means to find f of g of x and g of f of x. So I want you to pause the video, go ahead and find the inverse of f, call it g, and then calculate both compositions. When you're done, come back and we'll compare solutions. Okay, let's see how you did. So for the inverse, I came up with x plus 7 over 2. And then calculating both compositions, I got x for both. Therefore, remember the dot, 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 I hope, from geometry means therefore, f and g are inverses. Let's try another one. This one's a little more complicated because it's a rational function. So go ahead and find the inverse, call g of x, and then show algebraically that they are inverses by composing in both directions. Pause the video, come back when you're done, and we'll compare. Okay, let's see. This one was a lot more work. For the inverse, I got 5x plus 3 over x minus 2. So that's my g of x. And then again, composing in both directions. You can follow through the work. We end up with complex fractions. You have to get a single fraction. Worked across horizontally, sorry. Horizontally, we end up with this complex fraction. The x minus 2's will cancel out. Right? If we flip and multiply, they're going to reduce out. And then here we have plus 6 minus 6, and we end up with 13x over 13, which gives us x. For the second part, we have g of f of x. Again, we end up with a complex fraction. We want to get that into a single fraction. In the numerator and the denominator, the x minus 5's reduce out. The 15's cancel out. We're left with 13x over 13 again, which equals x. Therefore, f and g are inverses. So that concludes our lesson for 1.9. I hope you enjoyed it, and I will see you in class.